Hello everyone, my name is Manish Haveri. I'm working as assistant professor in the Department of Civil Engineering in Brahma University of Applied Science. So I'll be taking the course Engineering Mechanics. The content of the sessions are Introduction to Mechanics, Resolution of Forces, and then the laws which are associated with engineering mechanics. So under the introduction to mechanics, we are going to study different branches of mechanics and its importance. So we are also going to study about the engineering design, how mechanics is applied in engineering, and then what are the SI units we have to follow when we are going to solve mechanics problem. And then we are going to study about the basic idealization, that is for particle, continuum, rigid body, and then point force. So we are going to see what do you mean by particle, what do you mean by continuum, rigid body, point force. So with an examples there. So next we are going to study about the principle of mechanics with examples there. So coming to resolution of forces, we are going to study different examples on different types of bodies. That is, we have different types like rectangle, circle, irregular body, and then we are going to see how the forces are affecting the body and then how it can be resolved into different components. Like if the forces are inclined, how the structure or the body is going to behave. Next thing is laws. So coming to laws, we have different types of laws like laws of gravitation, laws of transmissibility, principle of physical independence of forces, principle of superposition of forces. Mechanics. Mechanics is a branch of physical science that is concerned with the state of rest or motion of bodies that are subjected to action of forces. That is, it is concerned with the study of response of bodies under the application of force. This branch deals with different types of structure when it is subjected with different types of forces. Branches of mechanics. Mechanics is divided into mechanics of solids and then mechanics of fluids. Mechanics of solid is further divided into rigid body mechanics and the deformable body mechanics. Mechanics of fluid is again further divided into fluid statics, or it is also called as hydrostatics, and then fluid dynamics. Coming to rigid body mechanics, it is divided into statics and then dynamics. Application of mechanics. Let us discuss some of the examples or some of the structures where exactly mechanics is applied. You can see on the screen the example of bridges. Okay, so bridges must be designed to withstand all the forces acting on it. There are different types of forces which are acting on the bridge. So vertical force is one of the force, horizontal force, and you can see wind force also, which is acting on the bridge. Okay, so when you apply such kind of forces on the bridge, we have to study the behavior of bridge. This is one such example where mechanics is applied. And the next one is robots. You can see in robots we have n number of joints. Okay, at each joint what are the forces which are coming over there, we have to study. This is possible only with the application of mechanics. Robot must be designed to grip objects with the appropriate force and carry out the motions assigned to it. Fundamental concepts and SI unit. In India, we are going to follow SI unit system. That is, international system of units are adopted there. Okay, so for different parameters, we have to use different units. So let me explain one by one. Coming to length, it is denoted as capital L, and the unit of this length is meter, and then it is denoted with small letter n. Coming to time, T, the unit is seconds. It is denoted as small letter s. And the next one is mass. The unit of mass is kilograms, and then it is represented as kg. And the next one is force. The unit of force is Newton. 1 Newton is equal to force required to give 1 kilogram of mass and acceleration of 1 meter per second square. When you want to convert force to Newton, one force is equal to 9.81 Newton. Suppose if the force applied is 10 kg, I want to convert that kg to Newton. How it is done? So 10 into 9.81, you are going to get the answer in terms of Newton. Then mass. What do you mean by mass? Mass is a measure of quantity of matter that is used to compare the action of one body with that of another. This property manifests itself as a gravitational attraction between two bodies and provide a measure of the resistance of matter to a change in velocity. In other words, the total amount of matter present in a body is known as its mass. The unit of mass, as I discussed earlier, is kilogram, and then it is abbreviated as kg. Is force. Force is generally considered as push or pull exerted by one body on another. It is the external agency which tends to change the state of body or a particle. Okay, when the force is applied to a body which is at rest, the body may remain in the state of rest or it may move with some velocity. And the SI unit of force is Newton. This, that is, you can see there, push or pull exerted by body on another is generalized as force. This interaction can occur when there is a direct contact between the bodies, that is, such as a person pushing on a wall, or it can occur through a distance where the bodies are physically separated. You can see the example displayed on the screen at the bottom side. Okay, example of the later type include gravitational, electrical, and magnetic force. In any case, a force is completely characterized by its magnitude, direction, and then point of application. This is very important. I'll repeat it once again. A force is completely characterized by its magnitude and then direction and then the point of application there. Displacement and distance traveled. The total linear movement made by a body to change its position from one point to another is called distance traveled by the body. The example shown here is, you can see there are 3 points: point A, point B, and then point C. Okay, we have to measure the distance between A and C. But in order to reach from A to C, the person has to travel from A to B and then B to C. What is the distance traveled by the person from A to B is 4 kilometer, and then from B to C it is 3 kilometer. If you want to measure the diagonal distance between A and C is, we have to apply Pythagoras theorem. Once we apply Pythagoras theorem, we are going to get the answer as 5. That is, if the person with bicycle wants to travel from A to C, that is the shortest path. Coming to basic idealizations. These are some of the technical terms used in engineering mechanics. That is particle, rigid body, and then point force. So particle, it is a body of infinitely small volume whose mass can be neglected and it is called as particle. This idealization helps as the geometry of the body will not be involved. And the next one is rigid body. A rigid body is one in which the positions of all the constituent particles do not change under the application of external force, such as the positions of different particles will not change. It is also the combination of large number of particles in which all the particles remain at a fixed distance from one another both before and after applying of load. And the last one is point force. When the effect of a loading is assumed to act at a point on a body, it is called as point force or else concentrated force. Particle. It is a body of negligible dimensions. In mathematical sense, a particle is a body whose dimensions are considered to be non-zero so that we may analyze it as a mass concentrated at point. We often choose a particle as a differential element of a body. We may treat a body as a particle when its dimensions are irrelevant to the description of its position or the action of forces applied to it. A body considered as a particle is taken as a unique point, which is generally the mass center of the body. And the last one is a particle has mass but no shape and dimension. This is very important. We have to remember this. A particle has mass but no shape and dimension. Particle is a dimensionless quantity. So coming to examples of particle. The size of Earth is insignificant compared to size of its orbit. You can see the example shown on the screen. Size of the Earth is insignificant when it compares to size of orbit. Earth can be modeled as a particle when studying its orbital motion. Okay, so that's why we are telling we have to neglect the size of the particle when compared to its entire mass. Okay, the same example is explained over here. The size of the Earth is insignificant compared to the size of its orbit. Next one is rigid body. It is an idealized body composed of large number of particles, all of which remain at fixed distance from each other. In addition to the tendency to move a body in the direction of its application, a force may also tend to rotate a body about an axis. Its shape and dimensions remain fixed under all loading conditions and at all time. A rigid body is made up of n number of particles. A rigid body is assumed to undergo no deformation under the action of applied force. Whenever you apply a body, the forces, the body is not going to deform. Deform in the sense deflect. Okay, these are some of the technical terms you have to remember whenever we are solving mechanics problems. And the next one is point force. It is an idealized force assumed to act at a point on a body. The example is shown on the screen. There is a vehicle and then there are 2 points of contact. The first point of contact is here and the second point of contact is here. Okay, a constant force exerted on a body by another is actually distributed over the area of contact between two bodies. If the area of contact is relatively small, the contact force between the two bodies may be considered as a point or else concentrated force. You can see here the area of contact is very small at this point. If the area of contact is more, then it is called as distributed force. But now here the area of contact is very less, so that whatever force is applied at this point, it is considered as a point force or else concentrated force. Next topic is Newton's three laws of motion. Engineering mechanics is formulated on the basis of Newton's three laws of motion, and the validity of which is based on experimental observation. Let us study the three Newton's laws of motion. Newton's first law. This law states that every body continues in its state of rest or of uniform motion along a straight line, so long as it is under the influence of a balanced force system. Okay, so let me explain this one. A particle originally at rest or moving in a straight line with constant velocity tends to remain in this state provided the particle is not subjected to an unbalanced force. Okay, so you can see the particle is represented as a circle there, and then there are three forces which are acting on a particle, that is F1, F2 and F3. Okay, so the body continues in its state of rest or uniform motion along a straight line. Okay, until and unless there is a force which is acting on it. Now this body will remain at its position, that is it remain in the state of rest until and unless these forces are acting, that is F1, F2 and then F3. The next one is Newton's second law. This law states that the rate of change of momentum of a body is directly proportional to the impressed force, and it takes place in the direction of force acting on it. That is, a particle acted upon by an unbalanced force F experiences an acceleration A that has the same direction as the force and the magnitude that is directly proportional to the force. If F is applied to a particle of mass m, this law may be expressed mathematically as F equal to ma. Okay, this is the particle, this is the force applied to the particle in the right direction. Okay, and then we can define using the Newton's second law as F equal to m into a. F is force applied, m is mass, and then a is acceleration. And the next one is Newton's third law. This law states that action and reaction are equal in magnitude but opposite in direction. That is, the mutual forces of action and reaction between two particles are equal, opposite, and then collinear. You can see there are two particles which are named after A and B, and then when you apply the force F on particle B, the particle B will exert equal and opposite force of F on particle A. That means there is an action and then reaction. The next topic is Newton's law of gravitational attraction. Newton postulated a law governing the gravitational attraction between any two particles. That is, it is mathematically represented as F equal to G into m1 m2 divided by r square. Let me explain all these terms. What is F? That is the force of gravitational between two particles. This is calculated with the help of the above formula. What is G? That is universal constant of gravitation. M1 and M2 are the mass of each particle, and r is the distance between the two particles. Force and its characteristics. This is very important. As I explained earlier, the force has the following characteristics. The first one is magnitude, and the second one is direction. The third one is point of application of force, and the last one is line of action. You can see a cube is displayed on the screen and there is an application of force on the cube. You can see there is a human hand which is pushing the cube further. You can see the cube is moving in the left direction. Okay, so the force has the following characteristics. As I told, the force has magnitude. What is the magnitude of the force here? It is 10 Newton. And then what is the direction of the force? It is towards the left side. And then what is the point of application? You can see this is the point of application of force. And the last one is line of action, in which line the force is acting. Okay, this is the line of action of force. Along this line of action of force, the force is acting. These are the four important characteristics of force. I'll repeat it once again. The first characteristics is magnitude, and the next one is direction. The third one is point of application of force, and the last one is principle of transmissibility of forces. The external effect of a force on a rigid body will not change if we replace a force of the same characteristics but acting at a different point along the same line of action. Okay, that is, we can change the position of the applied force only if it is along the same line of action, but the point of application of force can be different. Okay, so let me explain with an example here. Okay, this is the yellow color body is called as rigid body. It has certain mass m. Okay, initially this rigid body is subjected to force F, and the point of application of force is at point A, and then this is the line of action of force. Now I want to shift this force to some other point. Okay, so this is possible only if the force is applied on the same line of action. Now the point of contact of a force is point B. Okay, this principle of transmissibility holds good only if the force is shifted from one point to another point only along the same line of action. The limitation of principle of transmissibility. Principle of transmissibility can be applied only for rigid bodies and cannot be used for deformable bodies. It deals with the external effect of the force only. It does not depend or deals with the internal effect of the force, that is the self weight or the force due to gravitation. Principle of superposition. This principle states that the net effect of a system of forces on a body is same as that of the combined effect of the individual forces on body. You can see the example displayed on the screen. There are different examples. That is, you can see a force F1 is applied on a body of mass M, and then this A1 is the net effect of the force. And coming to this second figure there, F2 force is applied on the same body of mass M, and then the net effect of the force is A2. And coming to the third figure, okay, the force F2 and F1 are applied on the same body of mass M. The net effect of the force will be A1 plus A2. Okay, so coming to the last one, you can see force F1 and F2 are applied on the same body of mass M. The net effect is A2 plus A1. Now we can observe the net effect, how it is written. Earlier in the third figure, it is written as A1 plus A2. Now in the last figure, it is written as A2 plus A1. Okay, whichever force is nearer to the body, it is written as first, and then whichever force is which is far from the body, it is written as the next one. Principle of physical independent of forces. This principle states that the action of a force on a body is not affected by the action of any other force on the body. Action of forces on body are independent. In other words, the action of force on a body is not influenced by the action of any other force on the body. The next topic is resolution of force. What do you mean by resolution of force? What is the advantage of finding the force or resolving the inclined force? So let me explain one by one. So what is the definition of resolution of force? It is the process of splitting of a force into its two rectangular components, that is horizontal and vertical, is known as resolution of force. In other words, it is the technique of finding the components of a force along any direction is called as resolution of force. You can see in the figure shown on the screen, there is an inclined force of magnitude F. This I want to resolve it into two components, that is x component and then y component. We call we call this as x component. Why? Because it is along the x direction. This we call it as y component. That is, it is acting along the y axis. The angle made by force with respect to horizontal is denoted as theta. So this is the example there. Okay. So that is the upward and rightward force of the chain is equal to an upward force and a rightward force by 2 chain. Okay. So here there is a dog and then it is pulled with the help of a chain there. So this component, that is the inclined force, can be resolved into two components. One is the horizontal component and the next one is vertical component. The same is explained below here. This is the inclined force and then this can be obtained with the help of the vertical component plus the horizontal component. Let us see the example of this resolution of force once again. There is a particle or the body here which is circular in nature, and then this body is subjected to inclined force. The force F is producing simultaneous x displacement and y displacement. You can see this inclined force F is producing x displacement along with the y displacement simultaneously. And then the part of the force F which is producing this x displacement is called as x component, or else it is also called as horizontal component. This is denoted as Fx. And the next one is the part of the force which produces y displacement is called as y component, or else it is also called as vertical component. And then it is denoted as F. Components of a force. What do you mean by components of a force? As I already discussed in the previous slide, the two components are vertical component and then the horizontal component. The effect of a force along any specified direction is called as component of force. Okay, so there are two components for any inclined force, that is x component, which is represented as fx, and then the y component, which is represented as f phi. And the next one is how to resolve a force along any direction. Okay, let me explain with an example here. OA represents the force F. Okay, you can see here O, this is point O, and then OA represents force F, and direction theta is the acute angle made by the force with respect to x direction. This theta is between force F and then the horizontal direction, that is x direction. So cos theta is given by OA1 divided by OA. That is, if we consider this as a right angle triangle or the triangle over there, so cos theta is given by adjacent upon hypotenuse. So which is adjacent? It is OA1 divided by OA. OA1 is taken as Fx and then OA is taken as F. So Fx can be found out with the help of the formula, that is F equal to Fx equal to F cos theta. What is Fx? It is the x component of the force F, and then F is the applied force, and then cos theta, cosine of the angle made by the force with respect to the x direction. This So coming to the vertical component, that is Fy, we are going to use the same figure and then derive the vertical component. So let me take the same triangle over here, that is OA and then A1. Okay, so we are going to apply the sine function here. Sine theta is equal to opposite upon hypotenuse. What is opposite here? It is A1. What is hypotenuse? It is OA. So OA1 is taken as Fy. Okay, so you can see here OA2 is written instead of AA1. You can see from the figure AA1 is also equal to OA2. So OA2 is taken as Fy, OA1 is taken as Fx. Okay, so sine theta is equal to OA2 divided by OA, that is opposite upon hypotenuse. So OA2 is taken as Fy and then OA is taken as F. So Fy finally we can find out with the help of the formula, that is F sine theta. So x component of a force is given by the product of the magnitude of the force and then cosine of acute angle made by the force with respect to x direction. And the next one is y component of a force is given by the product of magnitude of the force and the sine of acute angle made by the force with respect to x direction. Okay, as we discussed earlier, Fx equal to F cos theta and then Fy equal to F sin theta. These are the two formulas we have to remember, and then we have to carefully remember this theta is made with respect to the x direction. These are some of the sign conventions we have to remember whenever we solve mechanics problems. Sign conventions for the direction of components. Okay, so whenever the force is applied towards the right direction, it is taken as positive. Whenever it is applied in the left direction, it is taken as negative. When the force is acting upwards, it is taken as positive. When the force is acting downwards, it is taken as negative. The horizontal component or the x component of a force acting along x direction is the force itself, whereas its vertical component is 0. That means you can see here theta is equal to 0. I'll repeat the sentence once again. The horizontal component or the x component of a force acting along x direction is the force itself. That means the force F is acting along the horizontal direction. That means there is no angle made by the force with respect to the x direction. That is theta is equal to 0 there. When we substitute theta equal to 0 in the equation fx equal to f cos theta, that is cos theta equal to 0, we are going to get the answer as fx equal to f. Why? Because cos theta is equal to 1. Okay, cos 0 equal to 1. Okay, similarly we can find out fy. Fy is equal to f sin theta. If we substitute theta equal to 0, sin 0 is equal to 0. 0 into f is 0. That means whenever the horizontal component is equal to the applied force in the same direction of that of horizontal component, then we can find out the fx and fy component. Fx equal to f and then fy equal to 0 over there. Okay, coming to the next example, that is x component of a force acting along y direction is 0, whereas its y component is equal to the force itself. That means fx equal to 0 and then fy equal to f. This is calculated by the following example. That is, whenever the force is acting along the vertical component, that is the angle made by the force with respect to the x-axis is 90°. We are going to substitute this 90° in the equation, that is fx equal to f cos theta. Now the angle is 90°, cos 90 is equal to 0, fx equal to 0. So we are going to substitute the same 90° in the next equation, that is fy equal to f sin 90°. Sin 90 is equal to 1, fy is equal to f. Earlier the force was acting in the x direction, fy was 0. Now the force is acting in y direction, fx equal to 0 then. Okay, and the next example is, if a force is inclined at 45° with respect to x-axis or y-axis, then its component will be equal to y component. Okay, so let me explain here. This is my y-axis, this is my x-axis. If the angle made by the force with respect to the x-axis and then y-axis is 45 degrees, suppose this is also 45° and then this is also 45° there. Okay, so x component will be equal to y component, that is fx is equals to f. Now let us discuss some problems on resolution. Okay, so the first question is, find x and y components of force in the following figure. Okay, so we can see in the figure there is 100 kilonewton force which is making an angle of 30° with respect to the horizontal axis. So let us find out x component and then y component of the given force, that is 100 kilonewton. Okay, what is the formula for fx, which we derived earlier, that is fx equal to f cos theta and then fy equal to f sin theta. Okay, so let us substitute the values of f and then theta here. The given force is 100 kilonewton, so let us take f equal to 100 and then theta is what, 30°. That theta is making with respect to x direction. Okay, so let us substitute the force F and the theta in the equation, fx equal to F cos theta. 100 cos theta. We are going to get the answer as 86.60 kilonewton there. So it is very important to mention the direction of force. As the value is positive, so it is acting in the right direction, that is towards the right direction. So and then it is denoted as the right arrow mark, or else it can be represented as plus 86.60, or else it can be represented as only 86.60, and then we have to mention the direction. Suppose if the value is minus 86.80, it would have been written as 86.60 kilonewton and the direction would be towards the left side. Okay, this is very important. We have to remember this always whenever we write the final answer of fx and then fy. Now coming to fy. So we'll substitute the value of f and theta in the equation fy equal to f sine theta. The value of f is 100 and the theta is 30 degree. 100 sine 30, we are going to get the answer as 50 kilonewton there. Okay, it can be represented as plus 50 kilonewton or as 50 kilonewton. The direction of y component is upward. That means we got the answer in terms of positive side. That's why the notation is upward. Suppose if the answer is negative, means it would have been written downward direction. This is how we are going to find out the x component and then y component of the given inclined force. This process is called as resolution of forces. Let us go to the next example. And the question is find out x and y component of the forces in the following figure. Now, here the inclined force of 20 kilonewton is making an angle of 30 degree with respect to the y direction. In the previous example, the force was making an angle of 30 degrees with respect to the x direction. Now, the force is making an angle of 30 degrees with respect to the y direction. Let us see how the resolution is done for such type of example there. So we have two set of equation, that is fx equal to f cos theta and then fy equal to f sin theta. Now as I said earlier, theta is the angle made by the force with respect to the horizontal axis or else the x direction. Now here the angle made by the force 20 kilonewton is with respect to the vertical axis. So we have to find out what is the angle made by the force with respect to the horizontal axis. We can see here. So let me draw a the x-axis or as the horizontal axis. So the angle made by the force with respect to the vertical axis is 30 degree. So the angle made by the force with respect to the horizontal axis will be 60 degrees there. Okay, so let me substitute this theta in the given equation, that is fx equal to f cos theta. What is the value of f? It is 20 kilonewton. What is the value of theta? It is 60 degrees. 20 cos 60, we are going to get the answer for fx as 10 kilonewton. Okay, so it is not represented, so it is better if we represent like this. So the value of fx is positive, that is plus 10 kilonewton or else 10 kilonewton. We have to mention the direction of force here. So the next one is fy equal to f sin theta. So substitute f and theta. We are going to get the answer as fy equal to 17.32 kilonewton. Again, the value is positive. That means the fy force is acting in upward direction. Okay, so this is how the resolution is done, and then fx and fy is obtained as 10 kilonewton and then 17.32 kilonewton. Both are acting in positive direction, that is fx is acting in positive x direction, that is represented towards the right direction, and then fy is represented towards the upward direction.
Now, the same problem can be done with the other method. Okay, so earlier we were finding out fx and fy with the help of the formula f cos theta and then fy equal to f sin theta. Okay, now as you can see here, this theta, that is 30 degree, is making an angle with respect to the vertical axis. So for that, what we did in the previous step is, like in the previous example, is fx equal to f cos 90 minus theta, right? So here theta value is 30. Okay, so can you just correlate this cos 90 minus theta? Cos 90 minus theta is equal to sine theta. Okay, similarly, we have sine 90 minus theta is equals to cos theta. These are the trigonometric function you have to remember. Now, so the same equation can be converted into f sine theta. Okay, so what is the value of f here? It is 20 kilonewton, and then sine theta is what? Sine 30 degree. Okay, so this is how you can solve this problem. Okay, so similarly, what we can do here is fy equal to f sine 90 minus theta. So we can take it as f cos theta. Okay, so I'll substitute here 20 into cos 30 degree. Okay, you are going to get the same answer here as that of previous one. This is how the second method is done. Okay, it's very simple, but you have to always remember the angle theta is made with respect to the x-axis. So when the theta makes angle with respect to x-axis, these two formula are valid. Suppose if theta is making an angle with respect to the vertical axis, the following expression will be effective. That is f sine theta and then fy equal to f cos theta. Okay, these two equations will hold good if theta is making an angle with respect to the vertical axis. Suppose if theta is making an angle with respect to the horizontal axis, the following expression will come into picture. That is fx equal to f cos theta and then fy equal to f sine theta.
So we have two set of equation, that is fx equal to f cos theta and then fy equal to f sine theta. Now, as I said earlier, theta is the angle made by the force with respect to the horizontal axis or else the x direction. Now here the angle made by the force 20 kilonewton is with respect to the vertical axis. So we have to find out what is the angle made by the force with respect to the horizontal axis. We can see here. So let me draw a the x-axis or else the horizontal axis. So the angle made by the force with respect to the vertical axis is 30 degree. So the angle made by the force with respect to the horizontal axis will be 60 degrees there. Okay, so let me substitute this theta in the given equation, that is fx equal to f cos theta. What is the value of f? It is 20 kilonewton. What is the value of theta? It is 60 degrees. 20 cos 60, we are going to get the answer for fx as 10 kilonewton. Okay, so it is not represented, so it is better if we represent like this. So the value of fx is positive, that is plus 10 kilonewton or else 10 kilonewton. We have to mention the direction of force here. So the next one is fy equal to f sine theta. So substitute f and theta. We are going to get the answer as fy equal to 17.32 kilonewton. Again, the value is positive. That means the fy force is acting in upward direction. Okay, so this is how the resolution is done, and then fx and fy is obtained as 10 kilonewton and then 17.32 kilonewton. Both are acting in positive direction, that is fx is acting in positive x direction, that is represented towards the right direction, and then fy is represented towards the upward direction.
Let us go to the third problem. Find x and y components of forces in the following figure. So in this figure you can see there is a force of 200 Newton which is acting in the third quadrant. The angle is not given, but the slope of the line, that is force, is given. You can see along horizontal it is 4 and then along vertical it is 3. Before going to this problem, let me explain you about the quadrants here. Okay, so in which quadrant x component and y component will be positive and negative here. Let me draw the reference axis here. This is my first quadrant, this is my second quadrant, this is my third quadrant, and then this is my fourth quadrant here. Okay, let me explain one by one. In the first quadrant, x component will be positive, and then y component will also be positive. That is, x will be acting in this direction, y will be in this direction. Okay, next one is in the second quadrant, x will be negative and y will be positive. That means x will be acting in negative x direction and then y will be in positive y direction. Okay, similarly for the third quadrant, we have x component is equals to negative and then y component will be negative. That is, x will be acting in negative x direction and y will be acting in downward direction. Similarly, in the fourth quadrant, x component will be positive. That is, x equal to this direction, that is right direction, and y will be negative. That is, it will be acting downwards. So this is what we have to remember properly. So this is my first quadrant, this is my second quadrant, this is my third, and then this is my fourth quadrant. Okay, so let me give an example of one force here. Suppose if the force is acting like this, we have to identify whether the x component is positive or negative, and then whether the y component is positive or negative. So what we have to do is, we have to draw the axis in the direction of force, that is along this direction and then along this direction, that is y direction and then x direction. This is the given force F. So here in this case, x component will be positive and then y component will also be positive. Suppose if the force is acting like this, what I will do? Again I will drop a perpendicular like this and then like this. So this is my x component which is negative, this is my y component which is positive there. Okay. So similarly, let me draw the force like this. So I'll just draw the x component here and then y component here. So x is also negative, y is also negative for this case. So coming to the last case, that is if the force is acting in this direction, let me draw the x component and then y component. So this is my x component which is positive and this is my y component which is negative. So this is how we have to remember about the components, whether they are positive or negative. Fine. So let me erase all this. Okay. So we have to find out the angle theta here. We have to find out the angle theta here with respect to the horizontal. So theta is not given, slope is given. So with the help of this slope, we have to find out what is the angle here. So if this is theta, this also will be theta. I'll consider the same triangle over here. Okay. So this is my theta here. This is my 90 degree. Okay. So I'll just apply tan theta. Tan theta is equals to opposite upon adjacent, that is tan theta is equals to 3 by 4. Theta is equals to tan inverse of 3 by 4 is equals to 36.86 degrees. Now we got the angle theta, that is with respect to the horizontal axis. Now we can write out the formulas, that is fx equal to f cos theta and then fy equal to f sin theta here. Now we should always remember that theta is making an angle between force and then the horizontal axis. Now our horizontal axis is this one. If the angle is made with respect to the horizontal axis, these two formulas will come into picture there. Now we'll substitute the value of f and then theta in these two equations. Fx equal to f, that is 200 cos 36.86 degrees, is equals to 160.02 Newton. Okay, so how we should represent is either minus 160.02 Newton or 160.02 Newton. In the bracket we have to mention the direction like this. You can see in this figure Fy equal to f sin theta is equals to minus 200 sin 36.87. Okay, so the answer is minus 120, or we can also write it as 120 Newton. In the bracket we have to mention the direction. This is how the resolution of the given force is done. Okay, so we have two different method here. So first thing is we have to find out the angle and then find out the x component and then y component. In the other method, without finding out the angle, we can solve this problem. Let me explain it. Okay, so I'll just write the formula once again, that is fx equal to f cos theta and then fy equal to f sin theta here. Now without finding out the angle, how should we solve this problem? Okay, so for the same given triangle, we'll find out what is the theta here. Okay, so sorry, cos theta. So let me take this one as theta here. Okay, so cos theta is equals to what? Adjacent upon hypotenuse. Which is your adjacent here? So it is my 4. What is the hypotenuse? It is 345. Okay, so this is 4 by 5. Similarly, we have sin theta is equals to opposite, that is opposite upon hypotenuse. Cos theta equal to 4 by 5, sin theta equal to 3 by 5. So we are going to substitute the same cos theta and sin theta in the above equation. Let me do it. Okay, so fx equal to f value. What is the value of f? It is 200 into what? Cos theta. Cos theta is equals to what? 4 by 5. Similarly, I'll go for fy. Fy equal to 200 into sin theta. Sin theta is equals to 3 by 5. So here the answer is what? 160 degree, sorry 160 Newton, and then here my answer is 120 Newton here. We didn't mention the sign here, so I'll mention it here. Okay, so either it is minus 160 Newton or 160 Newton. We have to mention the direction here. Similarly, for this, let me mention the sign. Either it is minus 120 Newton or 120 Newton, which is acting in downward direction. This is how the resolution of the given problem is done. Okay, so whichever I explained before was method 1, this is method 2. So in method 1, what we have done is, so we have calculated the value of theta by using this triangle, and then we found out the x component and then y component. In the second method, without finding out the angle of theta, we have done the resolution of the given force, that is finding out the x and y component. Okay, so that is, we with the help of the same triangle here, we have found out cos theta and then sin theta. Cos theta is given by adjacent upon hypotenuse, and then sin theta is given by opposite upon hypotenuse. So we have substituted this cos theta and sin theta in the equation, that is fx equal to f cos theta and then fy equal to f sin theta. Okay, so this is how the resolution of given force is done. I have explained different methods to solve these problems. The same thing has been solved in this slide, that is method 2. Without finding out the angle theta, they have done the resolution there. Fx equal to 160 Newton and phi equal to 120 Newton here. Thank you.